Hi all. So next we can have a last set of questions in discussion of crystal structures. So we'll go to question number 9. A narrow beam of X-rays with wavelength 1.5 angstrom is reflected from an ionic crystal with an FCC lattice structure with density of 3.32 gram per centimeter cube. The molecular weight is 108 atomic mass unit, where one atomic mass unit is 1.66 in raised to minus 24 gram. The lattice constant is. So the question is to find A. The given quantities are lambda, rho, and m. So actually the information of lambda is not required to find the lattice constant. So that we'll see here. So the information that we require is it said that it is an FCC lattice. Now in case of an FCC lattice, the atoms or the lattice points are present at every corners, and there is also lattice point at the center of each face. Then what is the total number of lattice points stroke atoms in the unit cell? So the contribution of corners would be 1, and the contribution of the face, each face is one half, and therefore the contribution from 6 face would be 3. So 1 plus 3 would be 4. So there will be total of 4 atoms or the 4 lattice points inside this unit cell, the FCC unit cell, and therefore the density by definition it is mass by volume. So there are 4 atoms present in this unit cell. So 4 times m would be the total mass divided by the volume. Since we denote A as a lattice parameter, the volume can be represented as A cube. And hence A would be equal to 4m divided by rho or raised to 1 by 3. Is equal to 4. What is m here? And the m is 108 times 1.66 into 10 raised to minus 24, and divided by density is 3.32 all raised to 1 by 3. So CGS system is used here. So therefore A would be in centimeter. Okay, so 1.66, 3.3 would be 2. Okay, and then 2108 would be 59. Okay, so how to do this? Sorry, not 59. It would be 54. Okay, so how to do this? So 4 into 54 all raised to 1 by 3. So better what we can do is 54 can be written as 2 into 27. So it can be 8 into 27, 10 raised to minus 24 all raised to 1 by 3 centimeter. Now 8 raised to 1 by 3 is 2, 27 raised to 1 by 3 is 3, 10 raised to minus 24 raised to 1 by 3 is minus 8, this much centimeter. Should be 6 into 10 raised to minus 10 meter, or the answer is 6 angstrom. So the answer would be 6 angstrom. Okay, so the next we can go for the 10th question. So in the above question, what is the sign of angle correspond to 111 reflection? Okay, so actually for the first question, the question number 9, the information wavelength was not required. We required only the information about the mass and the density, from which we can calculate the lattice parameter. But for this next question, the second question, the information of wavelength is required. So that is why they have given the information about the wavelength. Okay, so actually these two questions are connected questions. Okay, so both are asked in net June 2011. Okay, so how to find the sign of this angular corresponding to this reflection? So this basically comes from the Bragg's reflection. So we can have a small discussion about Bragg's reflection now. So better remove so all these different things here. Okay, so according to Bragg's law, we'll get the maximum diffraction when 2 dhkl sine theta equal lambda or multiple of lambda. So for the first order, it is simply equal to lambda. So this is what is called the Bragg's law. And what is the dhkl? This is a separation between HKL plane, and in general it is 1 upon square root of h square by a square plus k square by b square plus L square by C square. In general, for tetragonal or orthorhombic or cubic lattice, we can write like this. But for cubic lattice, A is equal to B is equal to C. So then DHKL can be written as A by square root of H square plus K square plus L square. Okay. Now, here we have already calculated the lattice parameter. The A is found to be 6 angstrom and HKL is given as 111. Okay, so if anywhere, if you look, if you see this kind of notation, so actually that shows the Miller indices. Okay, so this normal bracket represent the Miller indices of plane. Similarly, there are Miller indices for line, and usually the Miller indices for line is written inside the square bracket. Okay, but this is a normal bracket, so normal bracket represent the Miller indices of plane. Okay, so the HKL values of this plane is already given here, which is 111, and A is also found. So we have to calculate sine theta, and lambda is also given. So how to find sine theta? Sine theta is lambda divided by 2 times the DHKL. Lambda, what is lambda here? Lambda is 1.5 angstrom divided by 2 times DHKL is 6 divided by square root of 1 square plus 1 square plus 1 square, that would be 3. So it is equal to root 3. So 6, 1.5, so it will be 4. So root 3 by 8. So sine theta would be root 3 by 8. So the option B is the correct option. Okay, so that's about the question number 9 and 10. And the last question is question number 11. The question number 11 is actually to find the Miller indices of a plane. Okay, so that for that we can remove all these things. So the Miller indices of any plane, suppose if you have some plane which intersects the XYZ axis like this. Suppose these the interceptions we can denote by symbol P, Q, and R respectively. So if P is the X intercept and Q is the Y intercept and R is the Z intercept. So first we'll list down the X, Y, Z intercepts. Then after that we'll find its reciprocal 1 by P, 1 by Q, 1 by R. If all this 1 by P, 1 by Q, 1 by R is just integers, then that itself would be the Miller indices directly. But if any fraction is present, then we have to multiply with its LCM now to remove this fraction, and that final number would be the Miller integers. For example, if P is 1 and Q is 2 and R is 1 by 4, then 1 by P would be 1, 1 by Q would be 1 by 2, 1 by R is 1 by, sorry, 1 by R is 4. Okay, but now here there is some fraction is present, so the center one has 1 by 2, the 2 is in denominator. So if you multiply throughout with 2, we can remove that fraction. So if you multiply throughout with 2, it becomes 2, 1, 8. So the Miller indices of that particular plane is denoted as 218. So this is a way to find the Miller indices of any plane. So for that we have to know what are the intercepts of this plane to the x, y, and z axis. So how to find the intercepts, the x, y, z intercepts of for this particular question. So if you can able to find it, we can easily find out the Miller indices. Okay, so here the intercepts are not given here directly, but instead they have given 3 points: 0, 0, 1, 1, 0, 0, 1 by 2, 1 by 2, 1 by 4 are 3 points in that plane. So then from this information, how can I find the intercepts? So actually, this question directly giving two intercepts. 0, 0, 1 means it has z intercept 1, and 1, 0, 0 means it has x intercept 1. But the information about the y intercepts is not given here. Okay. So the one possibility to find the intercept is we can set up the equation. So first set up the equation for this plane. Okay, so this has 3 points: 0, 0, 1, 1, 0, 0, 1 by 2, 1 by 2, 1 by 4. So let us it have a general point x, y, z. So all these points are in a plane. Now we can define three lines here. So line connecting 1, 0, 0, this, the line connecting this, and line connecting this. So if you consider three lines or these three vectors, so these three vectors are coplanar, it is in the same plane, and therefore the box product of these three vectors would be 0. Okay, so we have three vectors here, so I can write the vector A, the vector B, the vector C. So the box product of A, B, C would be 0. How we can write the box product A, B, C? The symbol, the first vector, the vector A, can be written as x, y, z minus 1. The vector B would be 1, 0, minus 1, and vector C would be half, minus half, then minus 1 by 4. This should be equal to 0. So this is a way to find the equation for the plane, and we can find that the equation of the plane, as I am directly writing here. So if you do this calculation, we'll get this equation: the x plus y by 2 plus z minus 1 equal to 0. So from which we can find out uh, the intercepts. So if you put x equal to 0, z equal to 0, y equal to 2, that is a y intercept. And if you put y equal to 0 and z equal to 0, x equal to 1, that is x intercept. And if you put the x and y 0, the z equal to 1, that is a z intercept. So the intercepts are, so the x intercept is 1, the y intercept is 2, and z intercept is 1. So the 1, 2, 1, which reciprocal is 1, 1 by 2, 1. So we have to throw out multiply by 2. So it will be 2, 1, 2. So the Miller indices would be 2, 1, 2. So the answer is 2, 1, 2. So that's all about the discussion about the crystal lattice. Okay, bye. So best wishes to all of you for your UGC net examination or gate examination. So see you with the other questions later. Bye.